All right, we have started the recording. Welcome to our April learning event with a focus on computational thinking. And we'd like to welcome all of you. Next slide. Let us introduce ourselves. I'm Janine Nakakura, a resource teacher with the computer science team at OSID. And here's my colleague, Faith Ishihara. She is also on the computer science team, educational specialist. I'll let her introduce herself. Say hi.
Hi, everybody. Thanks for joining us.
So here's our agenda for today. So if you click on the link on the left, you will have access to all of our links, the presentation slides, the recording, when it's processed, and so on. So everything you need should be here in this agenda. Okay, thank you, Faye. So on the next slide, we'd like to know, what do you know about computational thinking? Okay, put your answer in the chat. And let's see, in the chat, I don't see any responses. But Faith, what do you know about computational thinking? Put you on the spot.
Oh, no pressure.
And no pressure.
Well, it's a series of strategies that make up a process to make complex problems simpler to solve.
Wow, what a great answer. You can do a webinar on computational thinking. Okay, so well, if we get any responses, we'll type them into the slide here so you can see them if you're watching the recording. Okay, next. So we're gonna see how much Faith really knows. Okay, so there's a pre-test here. No pressure again. So if you click on that link, it takes you to a pre-test with 10 questions, and you will not know the answers until you answer all 10 questions. Oh, and I see Faith already started the first question.
Yeah.
And she won't know what the answer is until she does all 10 questions. So if you want to know what the answers are, just check off, answer all 10 questions and then check your score, and you will see how many you got correct. And you could do that before and after this webinar and see how much you learned. Hopefully you'll get 10 out of 10 at the end. Okay, next. So I'll turn it over to Faith now.
So this Venn diagram shows how coding, computational thinking, and computer science all relate to each other. And we want to explain a little bit more about each of them. So Janine worked hard and found 4 videos that cover the 4 topics, but we can only show you one. So we're wondering which one pops out at you, really calls out to you to be shared.
Wow, abstraction looks really big, Faith, and it's highlighted.
Okay, could it be abstraction?
Maybe that one.
Yeah, let's take a look at that video. Okay, I'm gonna turn off my camera.
Abstraction is a problem-solving tool that helps you to simplify a situation by removing unimportant information and focusing on what is truly important in a given situation. Suppose you want to find the best bus route between 2 points in a city. There is a lot of information to sort through. However, not all of it is important for this task. For instance, the location of tourist attractions is not important for plotting a route. So when building your abstraction, you might choose to ignore that information. Highways and streets that buses do not travel along are also not helpful, since our goal is to find a bus route. So you might choose to exclude those. Names of neighborhoods are also not important for this task as well. In the end, as the abstraction designer, you might decide that the most important information is simply where to get on the bus, which bus to get on, where to get off the bus, what times to get on and off, and the general shape of the route within the city. These pieces of information, bus number, start, stop times, and route, are essential to the task and are included in the abstraction. Note that even though it features only 5 pieces of information, those 5 pieces can represent many different routes, because every one of them has a start, end, route, bus number, and times. Because abstractions focus on the key pieces of information, they are doubly useful. A single abstraction can represent a whole class of similar things, and they make it easier to understand each one, because there is not extra information present. Every abstraction is built with a purpose in mind. For example, here are 4 different maps, visual abstractions of a city. This map is useful for finding city neighborhoods. This map is useful for finding city streets. This one shows the public transportation of the city, and this one helps them find major attractions in the city. All of these maps show the same city, but each map uses the concept of abstraction to remove what is unimportant and focus on what is important to the user. Abstraction is the process of creating an easier to understand version of a complex system by focusing only on key information.
Yeah, so we kind of selected abstraction because it is one of a term that maybe we don't hear as much, and so we'll go through each of the concepts a little bit deeper. So here's a computational thinking at the heart of computer science practices 3 to 6 in the bubbles, and you can take a look at them and get a better idea. And we also included an infographic that shows that process of breaking down a problem, decomposing it, finding patterns, and abstracting what is necessary and forgetting or ignoring the unnecessary pieces of information, and then coming to an algorithm. So we're wondering, can computational thinking be taught in the primary grades? And definitely yes. And we'll show you some examples coming up. So as we mentioned, decomposition is breaking problems down to its smaller parts, pattern recognition, finding similarities and differences amongst the parts, abstraction, removing or identifying differences so the single solution can surface, and algorithms is creating the steps to solve the problem. So if we think about decomposition in math for younger students, how might we decompose the number 5? So put some thoughts into the chat. And we're gonna hear some thanks for thinking about that. And this is a game that students can play, and it shows all the different ways the number 5 can be decomposed, and have some fun learning about it.
Oh, sorry, I had my mic muted. I
Oh,
was saying 1 plus 1 plus 1 plus 1 plus 1.
I'm
Sorry.
sorry, Janine.
Yeah.
Thank you. Thank you. That's a good addition to the game. Okay, so looking at pattern recognition, where might we find patterns in the world around us? So share some ideas in the chat.
Well, I see in that, what do you call that?
Beehive?
Hive. I don't know if that's a bee. We have bees in our backyard. And
They're
they have,
not brown like that, yeah?
no, that's not a bee. That's something else. But that, what do they call that? They're
Cone? Honeycomb?
cone. Yeah. It's the same shape.
Yeah.
It's a 6-sided figure. What do you call that, Faith? A 6-sided figure.
Hexagon.
Hexagon. Yeah, they're hexagons.
It's,
Repeating.
yeah, that's so fascinating how they can do that. I mean, I think it's hard for a person to do that, but yeah. So if you think about it, all around us, whether it's something that is created or something that's just formed in nature, or the books we read, the numbers we work with, the stories we tell, they all tend to have patterns. And even dance steps or when you string up beads with students and building blocks, those are great opportunities to talk about pattern recognition and use that vocabulary, whether it's decomposition or pattern recognition, abstraction. If the students hear the vocabulary, and then pretty soon it becomes part of their language to share, so they're able to talk about their thinking and say, oh, I am trying to decompose this problem, or I'm looking for patterns. And then it just facilitates the communication. So here's an idea for abstraction. So when we talk about, are you going to adopt a pet? We may not necessarily need to know exactly what kind of food each type of pet would want to eat. But abstraction would be saying that you need to be able to care for your pet, feed your pet, give them a forever home, and those big ideas to as examples. So, and here's an algorithm example. So we have fun with this, following the steps of origami to make a box. And my girlfriend was telling me that she asks her daughter what is the algorithm of folding clothes when they're folding clothes together. And her daughter will tell her, you first you fold it in half, and then you fold it in quarters. And it's kind of nice to hear little ones be able to think through that. So let's see, oops. um
Oh,
oh, what
Faith,
happened?
Faith, Faith, why'd you turn your
Yeah.
camera off?
Oh no. My camera looks on to me, but is it off for you?
I
Yikes.
can't see you. I can hear you. Your sound seems to be working.
Okay.
Oh, Faith,
You
that
know,
happened last week. How come this keeps happening to you, man?
okay, so what did we do last week? Went to fix it?
Okay,
I
wait.
think
We have Fern here and Steve here. Maybe they can help us. Okay,
yeah.
so hi, Fern. Hi, Steve. Faith's
Thanks
video
for
isn't working, and
helping.
we need help. What steps
Oh,
can we
move
take
my
to solve this
mouse.
problem? Move your mouse over the video icon. That's a great suggestion. Try that, Faith.
Okay. Um, doesn't
Not
that doesn't
working?
seem to be.
Okay, last time you had so many tabs open.
Yeah, so I tried to clean up and turn my tabs off, close them
Okay.
up, but
Steve, you have any suggestions for her? You can talk to us too. You can just say it if you want.
No, I was a little confused when I came in and saw the screen. I'm assuming we're troubleshooting here.
Yeah. Okay. So, last week, this really happened to Faith last week. And so
Because it sounds more like something that would happen to me, and I'd be
it never
asking
happened.
you for help. I was never teaching during this video time so much, so I'm not very experienced actually with all of the video conferencing.
Okay, well, this really did happen to Faith last week.
oh,
So,
Fern,
Fern, you have any
Okay.
other suggestions?
Well, all right. So let's see. When you need to look at your settings. So where are your settings on your Zoom?
settings.
Where right?
Uh-huh.
So where are your settings? Is it an up? Is it a pop-up on the where you turn your camera on or off? So first off, is your camera on? Oh,
Yeah, it looks on for me.
But we can't. I just see your
How
avatar.
do you know it's on? What do you mean it looks on? Is it red or is it with?
She can see herself.
Yeah,
Right?
and my green light is on, and I see myself, but apparently you guys don't see me.
So last week, I told her just go out of the meeting and come back in. That's what we often do. The algorithm, Go out and come
Okay.
back. Maybe try that, Faith.
Yeah, since
that
we're
work.
finding a pattern here, I'll go
Yeah.
try that algorithm.
Okay. Wow, that was fast. She went out, came back in, and boom, it works. Wow, magic.
Thanks for your help, you guys.
You guys are so fun.
I love that problem solving.
Yeah, thank you for helping us. We appreciate it. Okay, next slide. So what
So
we'll do
fun.
is we'll record, for people who are watching the recording, we'll write down the possible solutions in the slides so they can see it later. Okay, next slide. So here's a game for you. You joined us at the right time. This is from our choice boards. We did this during the height of the pandemic, and we started with computer science. We did it like for 5 or 6 weeks. So we put the activities for computer science and group them by grade level. So if you click on that link above, you'll get the activities by grade level. But here's the sample from grade 5, week 8. Okay, so basically, puzzles are a good way to develop computational thinking skills because you have to, invent your own rules and algorithms for solving the puzzle below. So what we would like you to do is change the word Lisp, L-I-S-P, into Java, J-A-V-A. And you only have 5 steps or less, okay? And you must only change one letter of the word at each step. And it must be a real word in the English dictionary, okay? So because we have limited time, you can try solving it right now on your own. While you're trying to solve it, I'm going to put a hint into the chat, just in case.
Fern has
Oh,
her
yes,
hand
Fern.
up.
Yes.
I'm sorry.
Yes.
So which link are we clicking on in the slide, the CS choice boards? Is that where which you said click on a link, and I'm in the slides.
Oh, so that choice
Mm,
boards by grade level, if you're looking for more computer science activities by grade level, we organize them into grade level. But I chose the one just as a sample, and it's from grade 5, week 8, and this is it. So I just did a screenshot of it. But if you want more, there's a whole bunch of them. So
okay,
here's a
I
sample.
apologize.
No problem. We encourage you to ask questions. This is very interactive. So if you need a hint, because we're short on time, Faith and I did try this out ahead of time, and it wasn't as easy as it looked. Okay, but here's the word you could possibly use. You could come up with your own words, but lamp, limp, lava, and llama. Yeah, those are the words that might possibly help you go from Lisp to Java. So what order would what words would you use to get from Lisp to Java in order? Okay. So you can type it in the chat if you with our little hint here.
5
steps.
So
or
5
less.
words.
And you can only change one letter at a time on each step, and it must be a real
Steve,
word.
help me out here.
So we put it in the chat. We gave you a hint in the chat. So you could use those 4 words, llama, limp, lava, and lamp, to go from Lisp to Java. Steve, are you doing it in your head?
Yeah,
Okay.
limp would have to be first because you can only change one letter.
Ah.
Good thinking.
And the question that I would have is, can I change the order, or it looks like just that one letter slipped out and it became, so the order L-I and P has to stay there?
Okay, so Steve, you're saying after Lisp, you would put
Yeah.
limp. Okay,
Yeah.
so what would be the next word after limp?
Lamp.
Lamp, right.
There
Yeah.
we go.
Okay, so after lamp, what would you use after lamp?
Then llama.
Llama, and then
And lava and
lava.
Java.
Yay! You graduate from grade 5.
Without your help, I would never have. I'd still be here.
You
at
would
3
have.
p.m.
You would have.
Okay, but
Yeah.
so if we go to the
I'm a
next slide, the question is, how did we use computational thinking to solve that problem? And how can we use it across different content areas, right? So here's a little table that I found. And you can use computational thinking in different content areas, math, science, social studies, ELA. And I'm a science teacher. So, when I used to make the students write the procedure to the experiment that we were doing, well, that's an algorithm. Okay, so there we go.
Yeah.
Computational thinking in science. Okay, next slide. So just as a review, we keep pounding this in, but computer science is the 5 core concepts. It's more than just coding. But we did focus on algorithms and programming, just now, writing the steps. And then here are the standards in more detail across the grade bands from kindergarten all the way to high school. The core concepts on the left, the grade bands go across, and you can see standards. And some of them you're already doing, like writing the steps to a problem. Okay, next. Here are the standards we covered today, or we will be covering, or I think we did. Okay, so we broke down the steps needed to solve a problem, like, the number 5. How could you break down the number 5? Compare and refine multiple algorithms for the same task. So Steve, like, how we were trying to solve that puzzle from Lisp to Java, you kind of told us, hey, the second word should be this. So we were, thinking of different ways we could solve the problem, and Steve gave us his way of solving it. Okay. And then systematically identify and fix problems. So when Faith had that, glitch with her camera, you all helped us fix the problem, right? Okay, next slide. So here are the standards in more detail. We broke down tasks into simpler tasks. That's in all content areas. And then we looked at different ways to solve the same problem, like that word problem, right? From Lisp to Java. There's not one way to solve it, but we can put our heads together and think about different ways to solve problems. Okay, next. And then when Faith had that camera issue, we had to troubleshoot, right, Steve? I heard you say the word troubleshoot. And we helped Faith fix her problem. Okay, and this happens all the time. People's camera doesn't work, or their mic doesn't work, or they break up, or they freeze. Okay, so how do we solve those problems? That's computational thinking at work. Okay, next. So I'm going to turn it over to Faith. She's going to share a book from our ebook collection.
Okay, thanks, Janine. Yeah, so this time our book is Computational Thinking and Coding for Every Student. And I really enjoyed this book. It has a lot of printable online resources, really engaging lessons, simple explanations, and it's part of our statewide ebook collection. So here are instructions on how to access the collection, and you can borrow this or any other book, or we also have audiobooks to select from. Most letters in common with the word computational, and that person is gonna win prizes.
Hey, Faith, guess what? You froze. I think you froze.
Oh,
yeah.
really?
Yeah, we didn't hear you talking, and then all of a sudden, yeah, you were frozen, and then we could hear the tail
Oh.
end.
Okay, so did you hear the word is computational?
Yeah, I heard that part.
Okay, and then the prize is a CS for Fun puzzle book and CS50 puzzles that you and your students will really enjoy.
And
And
okay, Fern or Steve, whose name has the most letters in common with computational?
Well, if I go with Steven, then I'd have 2.
Oh, is that
With
your
a
real
T
name?
and a T and an N, that is my actual name. If I
Oh,
go with
wait.
Hanks, which is my last name, I still only have 2, A and N.
And Fern has 1 in, but you know what? You
Fern,
both.
I say we go with first names.
Okay, Steve is he has the most in common, but Fern, you're second place. And you will both get a prize because we appreciate your attendance here. And then feedback, if you can, we really appreciate any feedback. So I guess next slide, yeah.
the feedback, can you see the feedback slide?
Feedback form. I'll put the link in the chat.
Oh, Thanks.
And if you could, we'd really appreciate your feedback. There's our feedback form. And we are so happy that you could join us. We're thinking, oh, should we, like, no one's here. Should we, record? Yeah, we'll record because people might jump in halfway and boom. There we go. Okay, so I'm going to.
Okay, listen, you are awesome. I love that you guys get it in the sound bite of 30 minutes. You have it all organized.
I'm going to turn off the recording now.
Thanks,
hang on.
Fern.
If you want to ask questions or chat, I'm going to turn off the recording.